Okay, hi everyone. In this video, we're going to go ahead and discuss balanced chemical equations. So what does it mean if something is balanced? And how can we tell whether or not it is balanced? So let's go ahead and get started. Okay, so the first thing is the law of conservation of mass. And this is one of the most fundamental ideas for chemistry. So the law of conservation of mass tells us that matter is conserved during a chemical reaction. And we can take a couple different things out of this statement. First, that matter is not created or destroyed, it just changes from one form into the other. The other thing, or the second thing that we know, is that the total mass of the reaction, so the mass of what we put in, has to be equal to the mass of what we get out. And then finally, we know that the total number of atoms that we put in the beginning must be the same as the total number of atoms that we get out at the end. Now note, atoms are not the same as molecules. So I'm not saying the molecule number has to be the same. I'm saying the number of atoms has to be the same because molecules can have different masses. Okay, so chemical reaction equations that follow that law of conservation of mass are said to be balanced. Okay, so whenever someone says they have a balanced chemical equation, that means they have gone through the process of making sure they have the correct number of each of the molecules so that what we put in is the same number as what we get out. And the way that we can tell whether or not a chemical equation is balanced is using something called an atom inventory. Okay, so when you are using an atom inventory, there's a couple different steps involved. The first one is you're going to draw a vertical line directly underneath the arrow of your balanced chemical equation. Then you're going to list the elements involved in the reaction on both sides of that vertical line. And a little tip here, make sure you list them in the same order on the left and the right-hand side, because that makes it so much easier when we go to compare. Once we have the elements listed, we're then going to look at our equation and count up the number of atoms we have on the left-hand side and record that value, and then count up the number on the right-hand side and record that value. And then finally, we compare our inventory, so that listing of our atoms for the left-hand and the right-hand side, and we see if they are the same. If they are the same, then our equation is balanced. If our equation is, or if they're not the same on either side, then our equation is not balanced, or it's unbalanced. Okay, so let's go ahead and work through an example of this. So in this reaction, I have iron reacting with oxygen to give me iron oxide. So the first thing I need to do is draw that vertical line underneath the arrow. Next, I'm going to go ahead and list the elements that I have present. So the first one I have is iron. So I'm going to list that on both the left and the right-hand side of that line. And then I have oxygen, so I do the same thing. Next, I need to count up the number of each of those elements that I have. So for iron, I have one of those because I have no coefficients and no subscripts, so I know I'm going to have one. For my oxygen, I have a subscript of 2, so there's 2 of those. For my product side, for my iron, I have a subscript of 2, so I have 2 iron. And then for oxygen, I have 3 of those. So if I go ahead and look at my values on my left-hand and right-hand side, I see they're not the same. Iron's 1 on the left and it's 2 on the right. Oxygen's 2 on the left and then 3 on the right. So if I go ahead, this isn't balanced because the numbers are not the same. Okay, so let's try another one. So this is methane, CH4, plus chlorine gas gives us carbon tetrachloride and hydrochloric acid. So let's go ahead and get started with this one. So we draw that vertical line, and then we're going to list out the elements. So we have carbon, we have hydrogen, and then we have chlorine. Okay, so notice I am listing them in the same order on both sides, even though on the product side, they don't appear in that same order. It's okay. So now I'm going to list the number of each of the atoms I have. So on the reactant side for carbon, I have 1 of those. Okay, because remember that subscript of 4 with the CH4 only applies to the hydrogen, doesn't apply to the carbon. That 4, though, does apply to the hydrogen, so I have 4 of those. And then for chlorine, I have a subscript of 2, and I have a coefficient of 4. So that means I have 4 groups of 2 atoms. So 4 times 2 is 8. Now on the product side, for carbon, again, I have 1 of those. For my hydrogen, I have no subscripts, but I have a coefficient of 4. So that means I have 4 groups of 1 hydrogen, so that's 4. And then for my chlorine, I have it in 2 different spots, and we need to add those together. Okay, so first I have chlorine in the carbon tetrachloride, and I have 4 of those. And then I have 4 chlorine in the hydrochloric acid. So 4 plus 4 is 8. Okay, so if we go ahead and look, I have the same number of carbon on each side, the same number of hydrogen on each side, and the same number of chlorine on each side. So in this case, the reaction is balanced because I have the same number and type of atoms on both sides of my reaction. Okay, so now I have an example I want you to go ahead and try. So pause the video, do the atom inventory, and then figure out, is this balanced or is it not balanced? And then come back and we'll talk through this example. Okay, so if we go ahead and get started with our atom inventory, we draw our line, and then we're going to start our elements, which are hydrogen and oxygen. Now, in this case, for hydrogen, we have 2 of those on the reactant side and 2 oxygen on the reactant side. On the product side, I have 2 hydrogen, but only 1 oxygen. So even though the hydrogen are balanced on each side because the oxygen are not, this reaction is not balanced. So I hope this helps with figuring out whether or not reactions are balanced. If you have any questions, please let me know. Have a great day, everyone. Bye.